Okay, right, all of you. So we have discussed the Hadoop architecture, right? While storing the data, name node is the master HDFS daemon and data node is the slave daemon where it stores the actual data. Name node holds the metadata information of the cluster. Metadata means data about the data. In other words, it has the complete information about the cluster regarding the block locations, what are all the files, folders that are present in the Hadoop cluster. The complete information is shared with name node only. But how name node stores this metadata information, where does it stores the metadata information, we need to understand, right? Now, name node stores its valuable metadata information in two important files. One is FS image, and then the other one is edits log file. FS image and edits log file. So, what is this FS image and what is this edits log file? Whenever you are doing any, can you come forward? Why sitting last? Come forward. Whenever you are doing any modifications to the Hadoop cluster, a modification to the Hadoop cluster means Hadoop FS hyphen mkdir changes to the Hadoop file system. You are creating a directory means you are doing some modification to the Hadoop file system. Hadoop FS hyphen put, Hadoop FS hyphen get, all these are all modifications, right? Now, whatever modifications you do to the Hadoop cluster, name node will first write that modifications to the edits log file first. How does it write the edits log file? It logs every modification in the edits log file with a unique transaction ID. What is this unique transaction ID? For example, I have created Hadoop FS-mkdir test1. The operation name is creating a directory, right? So what name node does is, it will say, for example, starting 1, operation, creating directory name, test1. Who is the user? Is the user. Date, time, stamp, the permissions. Likewise, it will create every modification with a unique transaction ID in edits log file. Now, edits log file is a log appended journal file. Means every transaction will be appended. First transaction, second, third, fourth, fifth, sixth, like that. Okay. Every file you create or every directory you create in Hadoop consumes 150 bytes of name nodes memory. How much? So every file or every directory created in Hadoop, it will consume 150 bytes of name node memory. So as a rule of thumb, for 1 million transactions, 1 to 1.5 gigs of name nodes memory is consumed. Means name nodes hard disk is consumed. Whenever name node is writing these modifications into transaction logs, its respective metadata will be created into FS image file. Let me show you with a simple example, and then how name node stores this data we can explore. Okay, for time being, make sure that name node maintains its metadata information into two files. Those two file names are FS image and edits. Low. What is the command to start the cluster? Start hyphen all.sh, right? Visible, right? Command JPS to check the cluster is running or not. Start hyphen all.sh. If you have configured the cluster properly, JPS. So you have your name node, secondary name node, job tracker, data node, task tracker. What is the name node web UI port number? 50070, right? Localhost 50070. Now this will give you the name node up-to-date information. Browse the file system and everything. What is this? Name node storage. What is this? Storage directory. Type. What is the type? Image and edits. Where is this location of image and edits? App, Hadoop, temp. After Hadoop name node hyphen format, it has created a new DFS, right? Under DFS, you have a name. Name means name node directory. So go back to the terminal. CD, app, Hadoop, temp, DFS. Under this, you have three directories. One is name, data, name secondary. Name means name node. Data means data node. Name secondary means secondary name node. How the files are organized here. So let's go to CD name. Means name nodes directory. It has image in underscore use.log, previous checkpoint, current. CD current. Wonderful. Now what is this? FS image, edits log file. Okay. What is this version? cat capital version. What is this namespace ID? There is one number associated with this namespace ID. Whatever number is given to this namespace ID of the name node, the remaining nodes like data nodes should also have the same namespace ID. It is like the SSN number, Aadhaar card number for this cluster. Let's go to another terminal. CD, app, Hadoop, temp, DFS. In that you have data, right? Data means data node directories. CD, All the data node information will be stored here. Storage blocks being written current, CD current. Now here you see there is a version file, right? In this data node directory as well. cat version. What is the number? 797976. 797976 and before is 1361. Here also we have 1361 797976, right? Which says that the data node also has the same namespace ID and it should have. If data node namespace ID is different, then it will not be recognized into the cluster. Understand this? Okay. Now let's come back to, I'm closing all these terminals. Open a new terminal. SU space hyphen space SD user CD app Hadoop temp DFS name CD current. It's saying that FS image. What is the FS image size? 1493. Edits log file size in human readable format ls space hyphen LH. What is the edits file size? 1.1 MB. FS image size is 1.5 KB. I'm copying this data. Okay, I have mentioned this. Now what I do is I will do a name node restart. I will do a name node restart. What is the command to stop the cluster? Stop hyphen all dot sh will stop all your daemons. But if your requirement is to stop only one daemon, any daemon, it can be the name node, secondary name node, job tracker, data node, task tracker. The command is Hadoop hyphen daemon.sh. What is the operation you want to do? Stop. And here I want to stop only name node. Done. JPS. Whenever name node is down, your cluster will be unavailable. You cannot access the cluster. If you do Hadoop FS hyphen ls, what does it say? Retrying connect to server. Connection refused exception you will get. If you say it is trying to connect to name node, but name node is down, right? So finally failed on connection exception. Connection refused. Again, I will restart my cluster. Sorry, name node. Hadoop hyphen daemon.sh start name node. Your name node is running. Go here. Localhost 50070. Understand one line. What is this? I told you to remember this, right? So what is the time? 20 seconds, right? Refresh. So after restart, name node will go to a separate state called safe mode state. What is that safe mode state? We'll be discussing now. Now name node is out of safe mode. Let's go to the ls space hyphen LTR. Why this is not reflecting? Hadoop fs hyphen mkdir test one. Okay. app, Hadoop, temp, DFS, name, current, ls space hyphen LTR. Wonderful. Now earlier, what is the size of the FS image? 1.5 KB, right? Let's do one thing. Let me restart this machine once. Meanwhile, someone open your Cloudera as well, okay? I'll take later, not now. Keep your Cloudera machine also. Start hyphen all dot sh. JPS. Okay. Now go to the Mozilla Firefox. Okay. Localhost colon 50070. Now if you do a refresh, go to the storage part here. App Hadoop temp DFS name, CD, app Hadoop temp DFS name. In that you can see a current folder. Under current you can see edits and FS image. What is the value here? 1252 ls-lh, which is FS image size is closely 1.3 KB, which is very small. And what is the edits log file size? 1.1 MB, right? Actually, it is showing some wrong. Earlier it is showing 1.5, now it is 1.3. Let's see. There is some mistake here. Okay. So basically what happens is, I'll show you in another window. Whenever you are doing any modifications to the Hadoop cluster, the transactions or the modifications will be first logged into a file called edits log file. Okay. The edits log file is having all the information about the modifications. Name node will first log that modification to this edits log file, and then from this information, the name node will create the FS image information. FS image is like file system image, metadata information. If you see the farmer example, the farmer comes to the warehouse manager and the warehouse manager will give the small slip, right? It has only the details like name, date, time, number of rice bags, very small information. That is what will be logged in FS image, and edits log file has all the transaction information. Okay, we'll be showing what is there in the edits log file and FS image. Let me take you to that. You will better understand now. Name node maintains this FS image and edits log file in its hard disk and its RAM memory as well. What is the difference between hard disk and RAM memory? Huh? RAM memory is temporary, whereas hard disk is persistent, means permanent. And you can retrieve the data fastly from hard disk or RAM memory, right? So whenever you are retrieving the data from hard disk means it will be slow, a bit slow, right? Let me show you that, because hard disk is an electromagnetic device and seeking the data from hard disk normally takes time. Okay, now my data is stored in FS images and edits log file, and let's see what happens if I restart my name node, right? What is the operation name node is going to do? Let us see. RAM, it's a chip based, right? So in that the processor, it's a processor, not a storage space. RAM is not a storage space, it is a processing, right? So in that way, it will process the data very fastly. Okay, whatever you place it in RAM memory, it will retrieve the result very fastly, though it is temporary. Temporary in the sense, if you lose your power, all the data that is stored in RAM memory will be wiped out. Okay, now let us see this with one example and tell me what you observed now. Yes. Now terminal. Yes. SU space hyphen space SD user. Hadoop. Now CD app Hadoop temp DFS name CD current ls space hyphen LTR. Now what is the size of edits log file? 4 bytes, and FS image is 3056 bytes, like 3.0 KB. Now JPS start hyphen all dot sh. JPS. Wonderful. Now your cluster is running ls space hyphen LTR. What is the size of FS image? 3056. ls hyphen LH 3 KB. Edits log file size is 4 bytes, almost 0. Now I'm starting doing some operations. Hadoop FS hyphen MKDAR. Say for example, training 1, training 2. I'm just keeping my cluster busy. Okay. Training 3, training 4, training 5. Likewise, I'm just keeping my cluster busy. Now, once I do and see this ls hyphen LTR, let's see what happens. Why this is edit log is not displaying? No. That is okay. Hadoop FS hyphen LSR. You can see training 1, 2, 3, 4, 5, 6, right? Okay. Now new terminal. Control Shift +++. SU space hyphen space SD user. Hadoop. CD. App. Hadoop. Temp. DFS. Name. Current. LS space hyphen LTR. Yes. Now what is the size of the edits file? After doing some modifications, it has been jumped from almost 4 bytes to how much? 1 MB. For a small 5 transactions, I have seen a jump of edits log from 4 bytes to 1 MB. Where do this edits log getting that 1 MB? All that memory from name node only, right? Now the number of transactions you do or the number of modifications you do, what happens to the edits log file? It keeps on increasing 1 MB, 2 MB, 3 MB, 4 MB, likewise, right? So once edits log keeps on increasing, what happens to the name node's memory? It will decrease, right? Because name node's memory is consumed by edits log. For example, this is name node and it is having, say, for example, 1 GB. For example, assume that 1 GB hard disk. Out of this 1 GB hard disk, we have done some modifications now. After doing the modifications, the edits log file size has been jumped from 4 bytes to 1.1 MB. If you keep on doing modifications, what happens? It may reach to 2 MB, 3 MB, 4 MB, 5 MB, 10 MB, 20, 100, like that, right? So if edits log is increasing, what happens to this name node's memory? It will decrease. So if no one is observing, then what happens to the name node's memory? It may become full due to this edit log file. And if name node's memory is full, what happens? Does it take the client request? No, right? In some worse situations, it may fail as well, right? So in order to overcome this situation, what we do is, I'm just closing this terminal. Yes. Baba, voice, don't worry about voice. First of all, mind, okay? And you people are making a lot of noise. Okay. What should I do now? Okay, I'll increase my voice, okay? Now, what is the file size here? FS image file size 3056 in human readable format 3 KB and edit log file size how much? 1.1. Please write on this. Anyone, not all. So I'm storing this information in a text editor. So how to increase this font here? It's not getting increased. Preferences, okay. Which one? No. Okay, for time being, just make. Which one? Font and colors. This one. It's not coming. I just okay. Okay. Right now you can see, right? Thank you. Now what is the FS image size here? 3 KB and edit file size is 1.1 MB. Now what I do is I will restart the name node Hadoop hyphen daemon.sh stop name node. Let's see what happens. And again, I'm just doing JPS and then Hadoop hyphen daemon.sh start name node. JPS, your name node is running, right? I'll open a new terminal. Again, switch user to HD user. Hadoop, CD, app, Hadoop, temp, EFS, name, current. What do you see now? After restart, 3596 means closely 3.5 KB, right? 3.6 KB. And what is the size of edits log file? 4 bytes, almost 0. From 1.1 MB it became almost 0. This is after restart. Earlier, before restart, edits file size is 1.1 MB, but now it began to 4, almost 0. FS image size is 3.k, and now it has increased to 500. I mean, like very small 0.5 KB it has been increased 3.5. So what could happen in between name node restart? Before restart, we have a edits log file size 1.1 and FS image 3 KB. So whenever you are restarting name node undergoes a process called checkpointing process. What is this checkpointing process? During this checkpointing process, name node will go to safe mode state. Safe mode is like a maintenance state. It will not allow any modifications to the Hadoop cluster. Point number 1. Point number 2, it is like a write protected state. Okay. Now during this checkpointing node, name node will merge FS image plus all the edits log files to a new file called fs image dot checkpoint file. Now here we have 3.0, right? 3 KB file. Now here it is creating the metadata for this 1.1 MB. Name node during this restart, it is taking the as it is fs image file, and then it is creating the metadata for this edits log file, which is 1.1 MB, and then a new file it has been created 3.5 KB, means all this 1.1 MB queue size data has been converted into some 0.5 KB metadata information file, and then this 3.5 KB is the new fs image dot checkpoint file. Why name node is doing all these processes? In order to keep the edits log size in control. Because if edits log keeps on growing, there is a performance issue from the name node. So in order to keep name node in good health, it is going a process called checkpointing, where it merges the fs image and the edits log file by creating a new fs image dot checkpoint file. Are we clear till now, or any questions? Now let's see what happens again if I do one more transaction. For example, this is 3.6, right? Now, for example, ls space hyphen ltr. Yeah. Now again, Hadoop fs hyphen mkdir. For example, avd 20, 21. I'm just again making my cluster busy. 22, 23, 24, 25. Okay, so I'm just again keeping my cluster busy. Now let's see what happens again to my edits log file size. Again, what happened? From 4 KB to again 4 bytes to again edits log file has been sudden jump, right? Again it is increasing. Now again what I do is I'll copy this 3596. Right click, copy, go to this page. This is second process and second time I am doing. Control V. Now again I am restarting name node. What is the command to restart the name node? Hadoop hyphen daemon dot sh stop name node. If name node is down, entire cluster is down, right? Now JPS. Again I will start the name node. Again what should happen? Any guess? Now what is the edits log file size earlier after checkpoint? 3.5, right? 3.5 KB file, new file. Now what should happen? It will now take this FS image file 3.5 KB plus it will again convert this 1.1 MB file closely 0.5 or 0.6, 0.7, whatever. Just tell the 0.6 KB, let us assume. So what should be the new file information should have? Closely 4 or 4.1 KB, right? Which will be having the up-to-date information. So let's go to the terminal again. JPS. I'm just closing this because on the same window it will not display. So I'm opening this terminal. I'm opening a new terminal. What? Sorry. What? By doing what? We are not changing edits. We are doing modifications to the Hadoop cluster. It will not affect because name node is doing that process, right? Neither you nor me are doing, right? Name node is doing that process, right? So nothing will happen. It will fetch the metadata from edits log. Okay, good question. Now su space hyphen space sd user Hadoop. Again, tell me the path. App Hadoop DFS name current. Earlier, what is the size? Closely, it has increased, right, from 3.6 to 4.1. FS slight increase, but whereas edits log file has been decreased to 4 bytes. So the main intention of checkpointing process why it will crash name node? No. Here just I'm doing modifications means I am checking how the edits log is behaving. I'm not crashing name node, right? When name node will crash, if it doesn't have enough resources to handle that request, it may crash, right? Here doing 5 to 6 transactions, name node will not crash. Okay. Now I'm just doing my cluster busy to show how edits logs are behaving, how the size of the edits log is growing, right? Now see, within a span of 5 to 10 minutes, we have restarted name node twice, which is not a good sign because in production clusters, you should not restart name nodes frequently. But if you are not restarting name nodes and if you are not observing edits log means edits log can keep on growing. What could be the result? Next restart may take very long time, right? Because it should read all the data from the hard disk. Suppose I have kept the edits logs running for 1 day. So 1 day information, next restart, it has to read from the hard disk, which is again time taking process. During all this process, name node has to be down, which is not a good recommendation. So there must be someone who has to monitor this edits file, right? And do this checkpointing periodically. Do you agree or not? That someone is nothing but secondary name node. Okay. That someone is nothing but secondary name node. So the main, where is this? The main responsibility of secondary name node is to keep name node in good health, right? And to keep the edits log in proper size. Yes, ma'am. Which one? What? Huh? I mean, like internally, it will merge this FS image and edits log file. That will be taken care by the name node. The process will be handled by the name node, right? Means it will merge the FS image file 3.0 KB file, and all this 1.1 MB information is there, right? This will be converted into this FS image file, because FS image file is the metadata information file. Once you have the metadata information, for example, your Aadhaar card number is there. That is your metadata. If anyone found your Aadhaar card, they can get your clear details, right? Agree or not? Your name, address, etc., etc. Because your actual details, complete details will be in the Aadhaar card. Whereas your metadata number is your Aadhaar card number, right? So by getting the PAN card, they're telling your CIBIL scores and everything. How do they know that you're getting? They're knowing your complete details. They're taking your name. I mean, they're taking your PAN number. They're asking OTP, and then they're telling that this is your CIBIL score. Means every data is what is say is inserted with your PAN code number, right? Likewise, this edits log file information will be converted into this FS image metadata information. Don't think that 1.1 is stored. Not 1.1 MB of information is converted into metadata. That is handled by name node only, right? Perfect. Yeah. This, yes, yes. Where is the path we have just checked the FS image and edits? Why edit is affecting? Because edits log file size is increasing into MBs, whereas FS image has a slight increase at KBs. So how long it will take to MBs means it will take months. But whereas if you keep edits log running for days, your name node will be crashed, right? And again, FS image has only metadata information, a single lines. I will show you that as well. Whereas edit log has 150 bytes of information for every transaction. Understand that? Okay. Now, secondary name node. What is secondary name node and how does it behave? Let us see. Name node is the master HDFS daemon, right? This is the name node. And it has two important files. What are those two important files? FS image, file system image file, and edits log file. Edits log file, first of all, any modification, it will go to this, right? Now, we will configure a new server similar to the hardware of the name node. So that's why secondary name node is also a master daemon. Now, most of the viewers or participants, by hearing the name secondary name node, comes to a wrong perception that secondary name node is a backup of name node. That is not true, because only the metadata will be handled by name node, right? Secondary name node main responsibility is to do checkpointing. That's why in Hadoop, secondary name node is also known as checkpoint node. So how does it do the checkpointing process? Three ways. One is for every 1 hour by default, whether you mention or not, secondary name node will do the checkpointing process. What is again checkpointing process? Tell me. Merging FS images and edits log file and creating a new FS image file without stopping the name node, right? Earlier we have manually stopped the name node. Now with the help of secondary name node, we are not stopping the name node. But what is the process name node is doing during restart? Secondary name node is now doing. For every 1 hour, second one is edits log file size greater than 64 MB. Third one, what's the third one? For 1 million transactions. These three conditions we will trigger for secondary name node. Secondary name node. Now, the structure of metadata of name node and secondary name node will be the same. For example, the path, if you see here, yeah, now open this terminal. Now we are into which location? Name current, right? CD space 2 dots. Now you have another directory called name secondary. CD name secondary. Here also you have a current. Now here you see whatever information is there in name node, it is also having the same information in secondary name node, right? All of you. The structure of metadata for name node and secondary name node is same. Now, say for example, these two are communicating with each other. The time is 6 to 7. For example, 6 a.m. to 7 a.m. There are 100 modifications that were done to the Hadoop cluster. Now all these 100 transactions will be logged into edits log first, right? All of you. Name node will write all the edits modifications of 1 to 100 modifications to edits log file first. Exactly at 7 a.m. this secondary name node will trigger first checkpoint. It has been 1 hour. Hey name node, it's been 1 hour now. I need to do the checkpointing process. Why? Because to keep your health in good state, I have seen few edit logs increasing. So I will do the checkpointing process. Now edit logs, this secondary name node will also have the same information, right? FS image and then edits. So this is also having the 1 to 100 information. Now what does this secondary name node does? It will does the checkpointing process. Now it will merge FS image plus 1 to 100 edits log information, metadata information, and then it will create a new FS image dot checkpoint file, which is having all the information from 6 a.m. to 7 a.m. Do you agree? Once it creates a new checkpoint file with 1 to 100 metadata information, this is the new checkpoint file. FS image dot checkpoint file means all the information from 6 a.m. to 7 a.m. is stored here. This name node will store, secondary name node will store one copy in its hard disk, and it will send this up to date FS image dot checkpoint file to the name node. So name node is now having 6 to 7 information, right? FS image dot checkpoint, like 3 KB or 4 KB or 5 KB file. This is very small file, right? All of you. Edits log file 1 to 100 means let us assume that it is 10 MB. This 10 MB file has been merged to this FS image and it has created a 3 KB file. Now FS image is having 3 KB file which is having 6 to 7 AM information. Do you agree? Yes. Now, are we running the name node or are we stopping the name node during this process? We are running, right? We are not stopping. So this name node and secondary name node checkpointing process is internal. Outside clients or outside users do not know about this process, right? As name node is up and running, they may connect to name node and do the modifications, right? During this point, during this time, during this checkpointing time, there can be some modifications, right? For example, there were 50 modifications done to the Hadoop cluster. So where do these 50 modifications will be stored? For that, what NameNode does is, it will create a temporary file called edits.temp. What's the file? Edits.temp file. Now this edits.temp file has 101 to 150 modifications information. NameNode is having fsimage.checkpoint file, which is having 1 to 100 information, and this edits.temp file is having 101 to 150 modifications information, which says that NameNode will be having a complete snapshot of the entire file system, right? In other words, in simple words, NameNode is not missing not even a single transaction. Each and every information is handled by NameNode, right? Up to date information, correct? Now, once NameNode gets this fsimage.checkpoint file, and once editslog.temp file is logged, what NameNode does is, it will rename this fsimage.checkpoint file to fsimage, and it will rename edits.temp to edits. Now fsimage is having 1 to 100 modifications metadata, say 3 KB or 5 KB. Edits information is having 101 to 150, for example 5 MB or 6 MB something. Say for example after 730 or 740, there are so many modifications done and edits log file reached to 64 MB. This file reached to 64 MB. Immediately the secondary name node will does the second checkpointing process, not waiting for 1 hour. And again it will does the new checkpointing process and sends the up-to-date information. Otherwise it will wait for 1 million transactions. 1 million means 10 lakhs. So name node, depending upon these three conditions, either 1 hour by default, or edits log size reaching 64 MB, or for 1 million transactions, it will does the checkpointing process. Now, what are the important configuration files? What are the important configuration files? core-site.xml, mapread-site.xml, hdfs-site.xml, hadoop-env.sh. Wonderful. Masters, slaves. Now, what does this masters file consist of? Masters file will be having the IP address of secondary name node. We will be configuring the IP address of secondary name node in the masters file only. So that other important configuration files, core is having name node, MapRet is having job tracker, HDFS is having blocks, replications and everything. Hadoop-env.sh is having Java related. Masters file will have only the IP address of secondary name node. Slaves will have the IP address of data nodes. Right? Now you tell me. Okay. Now say for example 6 to 7 AM, secondary name node has received the FS images and edits log file, and it is doing the checkpointing process, and it has created a checkpoint file. Till now we are clear, right? This process may take 1 second or 1 minute, 2 minutes, 5 minutes, depending upon the edits log file size. Let us assume that this process has taken 5 minutes for our understanding. During this 5 minutes, name node is up and running, right? Now, during these 5 minutes, clients can be connecting to name node, right? They can do any operations. Suppose during these 5 minutes, they have done 50 modifications. Now, where do these 50 modifications will be stored? Name node will not store in this edits because it will be locked, right? Because it is sent to secondary name node. So, in order to store this temporary 50 transactions, it will create a edits.temp file. So, during this process, what is happening? All these modifications are logged into the temp file. Now, once name node receives this new file, up to date 6 to 7 information, it is renaming this file to original FS image file, and all the temporary modifications are again now renamed to edits file. So name node is having 6 to 7 informations, 1 to 100 modifications data, and again this edits log file is having 101 to 150 data, means 100 to 150 data. Name node is not missing, right? All of you, right? That is the main advantage of using secondary name node. Can anyone come here? Can anyone come here? Not Chaus, other one. Let's give opportunity to others. Anyone, please come. Read a bit loudly and stop whenever you see full stop. Yeah.
Secondary name node is one of the poorly named component in Hadoop. By its name, it gives a sense that it's a backup for the name node. But in reality, it's not. Lot of beginners in Hadoop get confused about what exactly secondary node does and why it's present in HDFS. By its name, you may assume that it has something to do with name node, and you are right. So before we dig into secondary name node, let's see what exactly name node does. Write the modification to the file system and to the edit log. Reads at startup and merges with edits log. Name node holds the metadata for the EDFS like namespace information, block information, etc. When in use, all the information is stored in main memory, but this information also stored in disk for persistent storage. The above image shows how name node stores information in disk. Two different files are first FS image. It's the snapshot of the file system when name node started. Second, edit logs. The sequence of changes made to the file system after name node started. Only in the restart of name node, edit logs are applied to the FS image to get the latest snapshot of the file system. But the name node restart are rare in production cluster, which means edit logs can grow very large for the clusters where name node runs for a long period of time. The following issues will be encountered in this situation. Number one, edit log become very large, which will be challenging to manage it. Second, name node restart takes long time because of lot of changes has to be merged. Third, in the case of crash, we will lost huge amount of metadata since FS image is very old. So to overcome this issue, we need to a mechanism which help us reduce the edit log size, which is manageable and have up to date FS image, so that load on name node reduces. It's very similar to Windows restore point, which will allow us to take snapshot of the OS so that if something goes wrong, we can fall back to the last restore point. So now we understood name node functionality and challenges to keep the metadata up to date. So what this is all have to be secondary name node. Secondary name node helps to overcome the above issues by taking over responsibilities of merging edit logs with FS image from the name node. Query for edit logs in regular intervals. update FS image with edit logs. Copy the update FS image back to name node. The above figure shows the working of secondary name node. First, it gets the edit logs from name node in regular intervals and applies to FS image. Second, once it has new FS image, it copies back to name node. And third, name node will use this FS image for the next restart, which will reduce the startup time. Secondary name node whole purpose is to have a checkpoint in HDFS. It's just a helper node for name node. That's why it's also known as a checkpoint node inside the community. So we now understood all secondary name node does puts a checkpoint in file system, which will help name node to function better. It's not the replacement or backup for the name node. So from now on, a habit of calling it's a checkpoint node.
Checkpoint node, right? Now let us see how this FS image is organized. Then you will understand. Yes. We are configuring master services as per our definition. What we said should be configured with high-end hardware configuration. So we are not configuring with small, slow and right terabytes hard disk we are keeping. So terabytes hard disk means it will not take 1 hour to complete the entire thing, right? Clear in it? No. Then tell me what happens. Edits log file size increases, right? Edits log file size increases, right? Whether it is 64 MB, say for example, for every 10 minutes, it is very huge. That's why we have ordered secondary name node to closely monitor that. So until and unless secondary name node is unable to handle that, then only it will fail. But most of the scenarios, secondary name node will do the checkpointing process without any issues. And again, this is 1.x version. As there is only single name node in 1.x version, we have a new feature added in 2.x version called name node high availability. So we have a pair of name nodes over there that we'll soon discuss in 2.x architecture. That is again up to you. When I'm saying default means whether you mention or not, the framework will take. You can keep it for 10 minutes. You can keep it for 5 minutes. That's again up to you. Depending upon your cluster, how your cluster is behaving, how your cluster is utilized. These are default values, right? How to? Which one? In secondary node, what I didn't get you. There is no need of secondary name node, right? Our main concern is primary name node only, right? So secondary name node is doing all the checkpoint process, and it is having the FS image checkpoint file means in the secondary name node also the edit log file size is decreasing, right? It is also having the KBs of data, right? I not understand your question only. You're telling for which file? FS is 1.1 MB. Edit log file is 1.1 MB. You are not understanding the concept. In name node, there are two files. One is FS image file, and then the other one is edit log file. Just now I have shown you. Now I will show you the metadata information, how it is organized. You okay? Yes. Can we? Then you need to keep the name node in safe mode. You cannot restrict edits log. Edits logs are restricted by the users, right? Whenever users are doing modifications, then only the edits log file size is increasing. But you cannot restrict the edits log. FS image, yes. You are in testing phase, then keep that name node in safe mode. No transactions will happen. Yeah. You can take the FS image. See, whenever you are restarting now means it will be having all the information related to now, right? When you are working at 9 a.m. means name node is having all the information till 9 a.m. right? Then what is the point of again restoring 8 a.m.? You are having all the information regarding 9 a.m. right? So that file you are already taking backup in secondary name node, and you are having fsimage.checkpoint file. That's what I'm saying. You need to keep name node in safe mode. That is an administrative command. We are not into that. Okay. Once we discuss about the safe mode, then you can get that point. Okay. Now, where do these FS images stores? Tell me. Wonderful. CD current. CD ls space hyphen ltr, CD name, and then current ls space hyphen ltr. Now you see there is an FS image file, right? Now your question, you're telling that, say for example, the time is 12 o'clock. So 12 to 4 o'clock, you will be doing some maintenance activity on the name node. That's your question, right? So during this 12 to 4 hours, you don't need your edits log to grow, right? So in that state, there is one command called safe mode command. You should keep name node in safe mode state. Then no transactions will happen. Okay. Now there are Hadoop. If you see Hadoop, if you do cat fs image, this is again like not a human readable format. This is like again sequence file format. Now, if I want to read the fs image file, how to do that? If I do Hadoop here, what is this? OIB. O stands for offline, I stands for image, B stands for viewer. Offline FS image viewer. Using this tool, you can convert that FS image into text file to check how the metadata is organized in Hadoop. So what we'll be doing is, clear? Now, Hadoop OIB. Wonderful. Now these are all the options. You can convert the FS image into XML file. You can do that into different options. And now I will do with text file only. So what I do is CLER clear ls-ltr. Now I am into this present working directory path, right? So I will use Hadoop OIB. Now I am using this tool. What is my input file? -I. What file I need to read? FS image. I want to store output as FS image, say for example .txt. I'm asking this OIB tool to convert this input file FS image into output as FS image.txt file. Done. ls space -ltr. Now you have a fs image.txt. cat fs image. Now here you see how the metadata is organized. Each and every modification information name node is storing in this way. This is metadata information, FS image, very valuable information. What does edits log file do? I will show you in 2.x version because OEV is not working in 1.x. So once 2.x is installed, then we will be discussing about edits log file. Till now, are we clear or not? Tell me any questions. Are any questions on this metadata information? Yes or no? Name node handles the metadata into two files. What are those two files? FS image edits. FS image has the metadata. Edits log has the transaction information with unique transaction IDs. Now what happens once name node restarts? Edit log files are replayed to FS image file, and then it will create a new FS image file by clearing all the edits file. This process is known as checkpoint. We will not be doing this checkpointing process manually. So there is one daemon for this process. What is the daemon name? Where do you configure the IP address of secondary name node? Masters file. So in what condition secondary name node will trigger? For every 1 hour, 64 MB. Clear, right? So till now we have discussed about name node, secondary name node, and data node. The remaining two daemons are job tracker, task tracker. We'll take a quick break, 10 minutes. Then we will discuss about job tracker, task tracker. 12:20, right? 12:30. Okay. Which name node? There is a dam. We have a inflow and we have a outflow, right? Hello. Yeah, hello. Who is this? Prabhakar. Madam, 1 second. I'll keep my friend online. He will tell the correct address. Okay. 1 second. Kapil sir, courier one is in on conference. Please talk. Hello. This is my number. Kapil, I'm staying with Kapil. Okay. Kapil, you tell your number, please. Okay, madam. Thank you. When will be the courier time? Hello. When do you do the courier? I mean, when do you deliver? Okay, madam. Okay, madam. Thank you. Kapil, please follow up. Okay. If they call you. Let him know not start. Why? What is the mistake you have done? Come here. What's your response? Data node and name node crash. Sorry. See, for everything there will be logs, right? Correct. First of all, you need to cd user local Hadoop logs. Under logs, you will get the complete information regarding all the daemons. Now you have an issue with data node and name node, right? So here you see job tracker ubuntu.log, secondary name node ubuntu.log, task tracker ubuntu.log. Here you see we have an issue with data node. So I need this file. Today's date you need to check. Data node, right? Copy this. Yes, tail space, tail space, tail, tail space 500 hyphen 500. 500 means last 500 lines you will get hyphen 500 space, paste that line, file name, enter. Wonderful. Now what does it say? All directories of DFS data are invalid. Expected RWX, R-X, R-X, right? But here you are given complete. So go to cd slash app, sorry, app Hadoop temp ls space hyphen ltr. You are given full permissions, right? So sometimes it is asking sudo space chmod hyphen capital R 755. Here it is asking while actuals are 777 755, right? So slash app. Let's see what happens. 755, not 751. Now you have everything perfect. What is the command to start a single daemon? Daemon.sh start data node. Because the issue is with data node, right? So first we are doing. Let's see whether you are getting the JPS or not. Your data node is up and running now. Now what is the issue with name node? Let us see. cd user local Hadoop logs. Now name node log you need to see. Where is the name node log? This is today's date. Copy. Tail space hyphen 500. Tail space hyphen 500 space. Right click paste. Enter. Wonderful. Now what does it say? Server name node exception. File system initialization failed. Server file system means name node hyphen format you have not done properly. Page up slowly. App Hadoop temp DFS name node. This is not done properly, right? It is everything information it will say clearly. Temp DFS name node current. This is not done properly. So enter Hadoop name node space hyphen format. It will ask yes or no because already you have created, right? Yes. Done. So Hadoop hyphen daemon.sh start name node task. Now data node is not running. Now I told you, right? App Hadoop temp DFS name ls space hyphen ltr cd current ls space hyphen ltr cat version. What is the namespace ID? 27539529. cd space 2 dots / DFS name, right? Enter. Now cd data current ls space hyphen ltr cat capital version. Now what is this 2753529 and it is having different ID, right? So what we do is right click, copy, sudo space nano version file, make it as hash button or remove that. right click, paste, because the data node should have the same namespace ID. Hadoop hyphen daemon.sh start data node. Data node is issue, right? All the 5 daemons working, right?
Yes. Sir, every time we need to do.
Every time not. From this now we have fixed it, right? It will work.
Sir, there is a command yesterday when you said Hadoop FS, you just type it and you type else and expose is the command. It is not showing the file for expose.
Expunge. Expunge means in order to remove that files from trash, we will use expunge.
So all the files from trash will be removed.
Remote, but normally the checkpointing process will take care. Until and unless you want to remove, we will be using expunge. In my 3 to 5 years, I have not used that command. Just for understanding purpose, if you want to remove the files in trash, we can do expunge, using expunge. It will clear all the files.
Permanently delete.
Permanently delete. Means while you have a file in recycle bin, you can recover, right? Once you are recovered, no need of that file again, right? So you can use expunge and delete that file. Or else you can use RMS.
So sir, then I'll just give Hadoop FS
Expunge and then the trash folder. Name node is not available. Say for example, 12:30 name node has been crashed. Till 12:30, name node will be having the metadata, right? FS image and edit log file information in its hard disk, right? Now we will get that information into hard disk and we will insert that hard disk into next server, new server, and then we will start that server. So that at what state name node is filed, from that state onwards, again it will start working.
In between the transactions which are queued, how that in between the transactions which are on the respective name, how those transactions.
It will not be queued because if name node is down, no transactions will be queued. They will get an exception saying that name node is down. No transactions will be queued. Only if name node is up and running, then only the transactions will be logged. Otherwise, it will not.
What is the role of secondary name?
Well, perfect. If name node is down, secondary name node is up and running. 12:30 information, but it will wait. It will check that it will connect to name node. It is down, right? So when and where name node is stopped, this secondary name node also will not get the data from 12:30, right? So either two ways. You can make this secondary name node as name node, or you can restart name node on a new server from starting with the where it left. Those are two options. So that's why in the Hadoop 2.x version, we have a new feature called high availability. Two name nodes are there. Even one is down, other will be up. Right? That I will tell.
And who is taking care of these things like name node is up and running? How
Hadoop admin. Basically, Hadoop administrators will be there. They will check the cluster. Huh. I'll show. I'll tell you. It is clearly saying that in core-site.xml you have missed this. So sudo space nano core Hadoop. Don't do any modifications here. Okay, configuration, property description. Where is the trash feature? You have not enabled, right? You need to copy, right? We need to add the trash feature here. Okay, start hyphen. Error means you have given space, right? That's why it is giving error. Now you add properly. Okay. Now
Last time he had modified, but after that he was
modified means he has given, say for example, sudo nano core hyphen, right? He has given space here. You should not give space. Okay. Now here you need to add that fs dot trash property here. Got it? And now restart the cluster. Clear? Andy? Yes, madam. Tell me. Sometimes, you know, if the properties are not working, then You can copy it into your here text editor, for example. Yeah. You can open text editor here. You do here and save it, and then open your Gmail here. You can attach it. That is one way. Editor. Display here, you see 800 is there, right? You can just change it to 1920. Apply. Then obviously it will increase your terminal size. It will come slowly. It will come. Clear? Start the name node. JPS. JPS again. Use JPS. Name node is not running. So why name node is not running? Please check the logs. Yeah, logs and then start the name node. Okay. Afterwards, I'll tell. Once you pay attention in the class, first thing, okay, it will load into your mind first. Then you hear 2 times or 3 times, your mind is very powerful. First of all, listen what I'm saying. Recording later part. Don't keep in mind that okay, I have a recorded session, I will have. First, understand careful running notes. Okay. Yeah. Okay. See, there were some challenges regarding this recording and everything. Please pay attention in the live class. Okay. Live class and keep your registered in your brain what I am saying. Then it will be for you easy for you while listening these recording sessions or not. Recording sessions means like for practice. Main is live session only. The more you are attentive in this class, right? You pay attention in this live class, then recorded sessions and everything are like for practice purpose, right? Now we have discussed about all the 3 daemons. Now, what are the remaining two daemons left? Job tracker, task tracker. Hadoop, when it comes to Hadoop, there are two components. What are those two components? HDFS and MapReduce. I'll repeat. HDFS, MapReduce. HDFS is the storage part and MapReduce is the processing part. When it comes to storage, we have discussed the architecture, like name node is the metadata information, data node is the slave daemon, secondary name node handles the checkpointing process and everything. The remaining two daemons are job tracker, task tracker. These two daemons are related to processing part. What is processing part? Simply storing the data doesn't give you any meaningful information, right? So you need to process the data. How do you process the data? By writing some code. As Hadoop is completely written in Java, you normally write Java code to process this data that is present in HDFS. So whenever you're writing a program and submitting the Hadoop cluster, the program should be in the form of a jar file. What is jar stands for? Java archive file. So whatever program you are submitting to Hadoop cluster, that program should be in the form of a jar file. Normally, developers write programs using integrated development environments like Eclipse, NetBeans. From there, the code is imported as a jar file. That process will be showing in 1 or 2 days. But every program is submitted to Hadoop cluster in the form of a jar file. Now, in a Hadoop cluster, if anyone asks, 5 jobs are running, 10 jobs are running, which is nothing but 5 applications are running, 5 programs are running. A jar file is nothing but a program. It's a job. One job is running means I'm writing one code and I'm submitting it to Hadoop cluster. Am I clear? Now, this is my cluster, for example, single node cluster. And if I do start-all.sh, it has name node, secondary name node, job tracker, data node, and task tracker. Right? Now, suppose I have 192 MB data. This 192 MB data stored in Hadoop, how many blocks in 1.x version? 3 blocks, right? 64, 64, 64. B1, B2, and B3. As the replication is 1, no other copies will be stored. The storage part is done. Suppose this is geodata. Now I have written a program to process the geodata. Right? Storage part, name node and data node will take care. Now this is processing part. So who will be taking care of the processing part? Job tracker. So what exactly is job tracker is? Job tracker is the master processing daemon. Master processing daemon. Name node is the master storage daemon. Job tracker is the master processing daemon. So what is the main function of job tracker? The main function of job tracker is scheduling and monitoring. It will schedule the jobs and it will monitor the jobs. How does it schedule and how does it monitor? We will be discussing now. I have submitted a job to process this B1, B2, and B3. Job tracker will now take the request. But how do job tracker know that it should work on these 3 blocks? Does it have any metadata information? Does it have metadata information, job tracker? No. Who is having the metadata information? So whenever job tracker is getting any client request to process, it will internally checks with name node. Hey name node, I was given a job to process some data, but I do not have the complete information regarding the blocks. As the entire metadata is with you, please share me the block details. Every block has a unique block ID. So name node, after checking that, it will say that, okay, your data is in 3 blocks, B1, B2, B3. Go ahead and process. Now this job tracker will schedule the job. And who is the slave daemon for job tracker? Task tracker. So job tracker, whenever it gets the job request and metadata information from name node, it will send that code, or it will ask the slave daemon task tracker to start processing the job, to start processing the code. Now task tracker has to obey the job tracker because it is the slave and job tracker is the master. So how task tracker will process is, it will internally create a new JVM. Like C programs, how a C compiler is there, for Java programs, there should be a JVM, Java Virtual Machine, an environment where it has the ability to run the Java programs. So this task tracker will create a new JVM in which it has by default 2 map tasks and 2 reduce tasks. The name map tasks and reduce tasks are derived from map reduce. Mapper phase, reducer phase. Map task and reduce task. Here you need to understand point number 1. Mappers and reducers run in isolation, means they run independently. They will not involve in each other's work. Mappers do mappers work, reducers do reducers work. Mappers will not involve in reducers, reducers will not involve in mappers. Right? Now, John Tracker asks this task tracker to process the blocks. How many blocks are there here? 3 blocks. But here, how many mappers are there? 2 mappers by default. So, the job tracker will tell the first mapper to process block 1. Mapper 2 will process block 2. Now block 3 has to wait. Block 3 has to wait because there is no mapper right available until either of these 2 mappers have completed processing. Whichever completes processing first. For example, if mapper 1 has processed B1, then again this task tracker will say, okay, mapper 1 is free, right? So please process the next block. During this process, all the task trackers will be sending heartbeat signals to not name node, job tracker. Like how data node shares the heartbeat signals to name node, these task trackers will share the heartbeat signals to task trackers saying that there is no issue from their side. They are up and running. And they will send the periodical update or periodical progress of the job. That is 10% completed, 20% completed, whatever job that is completed, it will send the information to the job tracker. Once mappers have done, then reducers will start. Reducers, it will take 1 reducer or 2 reducers depending upon the job. Once mappers and reducers are done, the output is sent back to the job tracker and job tracker will send the output to the client. Looks simple. Let me share you with one example and then we will go into more complex way of this job tracker task. Okay. What is the name node web UI port number? 50070. Likewise, job tracker also has its own port number 50030. What is that? Local host means the server where job tracker is running. Now I will clear this CLER clear. Now I'll go here. Just give localhost colon 50030. What does it say? Hadoop map reduce administration. The cluster details of the single node. Is there any map task running now? We have not yet submitted any job. So 0. Running task 0. Total nodes, how many nodes are there? 1. That is task tracker, Ubuntu task tracker, only 1. How many slots are there? Map task capacity, how many? 2. Reduce task capacity. So total, how many tasks are available? No blacklisted nodes, no gray nodes, and everything. There are no running jobs here. So this page will give you the complete information. Now let us submit one job, means one program, right? In the introduction classes, I have told you 3 modes of installing Hadoop. What are the 3 modes? Standalone Java, standalone mode, pseudo distributed mode, and fully distributed mode. In standalone mode, what we have discussed, it is for testing purpose. We will simply test the framework provided examples, right? Now here, if you see, this is a pseudo distributed mode, and where we have installed Hadoop, user local Hadoop. Now you see, the framework has given you few jar files, correct? Hadoop examples 1.2.1 jar, Hadoop core 1. These are all jar files. How do you run a jar file then? Type Hadoop here. If you want to run a file system command, Hadoop space fs, right? Hadoop jar. See, Hadoop fs means file system commands. There is another command called jar. To run a jar file, what is the command we need to give? Jar. Hadoop space jar. So Hadoop space jar. It is asking where is the jar file to run. Now I have this examples jar file, right? Select this. Right click. Copy. Hadoop space jar. And then what is the jar file? Examples jar file. Enter. An example program must be given as the first argument. Valid programs. So the framework is giving you few default programs. Aggregate count, DB count. What is the value of pi in mathematics? 3.14 or 15, 22/7, right? Now the framework has given you a map reduce program that estimates pi using this Monte Carlo method. So we will be testing the value of pi using a map reduce program. Now what I do is upward arrow, pi I will write. The usage, pi estimator, it is asking us to provide n maps and n samples. N stands for the number. So here what I do is I have a very little RAMs, right? So upward arrow, two mappers, two maps, and for each maps, two samples. Understand what? See, number of maps, two samples per. Now running job for every job there is a job ID. Task tracker will be running now. Task instance, map 0%. First mapper phase will do 50%, 100%. Then register phase will start. Reduce 33, 100. These are all job counters, how the job is behaving. We'll be discussing that. Now, the value of pi is estimated close to 4 from this program. Let's go to the Mozilla Firefox now. Give a refresh. Now here you see completed jobs. the list of jobs will be displayed here. What is the job ID? 22/04/2022. Today's date, right? This name is 22/04/2022. This is system date 001. Started at April 23rd. System time. Priority is normal. We have priorities like, high priority, low priority, and everything. Here you see priority and everything. Then what is the, with which user you have submitted the job? What is the name of the job? Mapper is 100% completed. We are using how many map tasks? 2. Here in regis, how many registers are used? Only 1. Though it has 2 registers, 1 register is enough. Now, let me show you in other way. Now I will take CLE clear. Now I will run another job. Now I will give 3/3. How many mappers will be now? 3. For each mapper, 3 samples, right? Now here if you see, I'll go to refresh. Now here you see total submission, occupied map slots, how many? 1. Running map task 1. Refresh. Refresh. Now you see occupied map slots 2. Refresh. Refresh. Now again map slots decrease. Now check the reduce slots. Reduce slots if you see. Switch on that. Reduce slots 1. Refresh. Reduce slots also done. Now again, no running tasks. 2 jobs submitted. And again, we have back 2 map tasks, 2 register. If you see the job 002. 1 second. Let me check whether this job is completed or not. Job finished in how many seconds? 36.470. Now, as per our discussion, the task tracker will be running the map tasks, right? How do these map tasks will be running? I'll be showing you in the other terminal as well. Control++, SU space, -space, SD user, Hadoop, JPS. First map task will be running, right? If I give 2 map tasks, two map tasks has to run. Then 1 reducer task is running, right? Now here you see enter CLE clear. Again I'm giving this job 3. Now JPS if you see child is there, child. Again JPS. Now there is only 1 child. JPS, 1 child is running. Now if you give, the job is completed, no childs will be there again. Child jobs means child JVMs means which are processing the job. Not understood? Okay, I'll tell you. So basically, job tracker is there, right? Master daemon. Job tracker first of all takes the client request. It has to process the job. Now, how does it process the job? With the help of task trackers. In this case, there is only 1 task tracker. Now, this task tracker has to process the code. How it is processing? With the help of 2 map tasks and 2 registers. The storage part of Hadoop is known as HDFS and processing part is known as MapReduce. MapReduce is nothing but a parallel programming model. I told you park example, right? If 5 people do the same work, same time, the time will be reduced. That is the MapReduce technique Google is using. Now, here in this MapReduce case, for every MapReduce job, there is a map task and reduce task involved. Mapper phase and reducer phase. Reducer phase aggregation takes place. Now, by default, every task tracker will have 2 map tasks and 2 registers. I have submitted a job here, for example. Huh? In the map phase, the given business logic is the given output is divided into multiple outputs, same or different output. Whereas in register phase, aggregation takes place, summing operation. Divide parts and then finally aggregation will take place in register phase. Okay. Now if I'm running a job here, for example, Hadoop, John, Hadoop means who will be taking care of the request? Job client running. There is a job running now. Map 60%. Mapper phase is doing. Once mapper 100 phase is done, register phase will start. Who is doing this mapper phase and register phase? The task trackers. Correct. The task trackers with the help of tasks they are doing, right? So to make sure that you understand this, now I'm giving 4 map tasks, and for each map task 4 samples. Enter. Now here if I give a refresh, first of all understand this map slots. How many map slots are there? Now how many map slots it is going? Job is completed or what? It will be very fast. Okay. So wait. Job tracker will be scheduling the jobs and monitoring the jobs. Like if there are any failures in this map tasks, if there are any failures in the registers, job tracker is responsible for rerunning of the job. It will check for the task tracker status. It will check, it is completely responsible for the life cycle management of that particular job. Now say for example, clear. Now if I stop name node, for example, Hadoop hyphen daemon.sh stop name node. You want to check that? What is this case with edit logs? Here we are not doing modification, right? We are running a job. We are running a job. Job and edit logs are not interconnected, right? Understand? Whenever you are doing any modification to the Hadoop cluster like storage part, then only edit logs comes into picture. Job tracker comes into picture when you are processing the data. Don't confuse with the help of map task and registers, this job tracker will run. Okay. Now my name node is down. My name node is down. Let us see if I can create a directory or not. Hyphen mkdir test 1 2 3. What happens? You cannot create, right? Because name node is down. The entire storage part is down. So you cannot create a directory. It says that connection refused. Okay, now let me run the job as well, whether job tracker is running the job or not. Job tracker internally checks with name node, right? If name node is down, what happens to job tracker? Metadata is not retrieved, right? So will this job run or fail? Fail. So it is connecting to name node and it is not getting the result. So if name node is down, both storage part and processing part are down, will not be working. Okay, let's see this now. Now, SPOF, what is the meaning? Single point of failure. So that's why, that's the reason in 1.x version, we have a single name node. If name node is down, you cannot replace it. Okay, there is no option, right? Now I will start the name node here, Hadoop hyphen daemon.sh start name node. JPS. Now your name node is running. What I do is, I will stop the job tracker. Hadoop hyphen daemon.sh stop job tracker. Job tracker stopped means processing part, right? Whenever you submit any job, who is responsible to take that request? But now it is down. Now let us see whether your job is running or not. What happens? Tell me. If I run a job, name node is up and running, but job tracker is down. Then what happens? Tell me. Trying to connect to job tracker down. So if job tracker is down, processing part is down. But if name node is down, storage and processing part both are down. Here, even though process part is down, I can still create my directory. Hadoop fs-mkdir test 1, 2, 3, 4. It is creating, right? So what you do today is, we have discussed the metadata information, right? Okay. You download one notebook. What is that notebook name is? Control A, Control X. Go to Chrome. Do Google. Just type PDF share plus practical Hadoop ecosystem. Practical Hadoop ecosystem. The first link will tell you download practical Hadoop ecosystem. All of you. Practical Hadoop ecosystem. If you download this book, if you click on this book, it will take you to this practical Hadoop ecosystem. Just click on the download PDF, it will download. Once it is downloaded, you can see the path as this book. Now, once you download this book, there is HDFS daemons. What is the first one? Name node. Name node. And then you have a name node and its properties. Secondary name node. What does this checkpointing process? Everything clearly written. And then you have a data node followed by job tracker and task tracker. Please go through this map reduce daemons today. Your assignment for today is, please write down. Download practical Hadoop ecosystem PDF HDFS architecture, which covers name node, data node, and then second one Hadoop FS commands. Third one name node, metadata, which covers FS image, and then edits log file. Okay. Fourth, job tracker. So no, secondary name node. And fifth one, job tracker and task tracker. I need everyone to have a one-time read this book today. Okay. While coming tomorrow, what you do is create a new Ubuntu instance. Create a new Ubuntu instance, like create virtual machine, new Ubuntu instance. I will tell you 2.x version. And once again, I will tell you the job tracker, task tracker with examples. Okay. 2.x installation. And then we will check the differences between 1.x and 2.x. Okay. Why we are using 2.x? What are the new features that are added in Hadoop 2.x? We'll be discussing. Am I clear? This video you will be getting in a couple of hours. Okay. You come. I'll tell here. Okay. stop